So in section 5, we're going to talk about the law of sines. So we've previously been talking about how to solve right triangles, but not every triangle is going to be right. Those are called oblique triangles. So to do this, we use the law of sines and the law of cosines to solve those triangles. So when we start with the law of sines, you're given sides A, B, and C, angles A, B, and C with sides A, B, and C that are the opposite of their angles. So for all triangles, we have the law of sines is then sine of A over its side equals sine of B over its corresponding side equals sine of C over its corresponding side. So if you're given a triangle and the necessary information, you can use the law of sines to solve for missing sides and angles. But you can't use it all of the time. There are certain cases that it works. So, needed information in order to solve a triangle using the law of sines. There are two cases. So you either need two angles and one side, or you need two sides and one angle. So in both of these cases, you have to have an angle. The law of sines cannot be used if you don't have at least one angle in both cases. And we're going to go more into each case and talk about what's called the ambiguous case. So let's start with probably the easiest case to use the law of sines, and that is when you are given two angles and one side. And this would be that the side is between the two angles, also known as angle side angle if we were dealing with similarity. So given two angles and one side, we can find all over parts of our oblique triangle. So the nice thing about this is the very first thing in our triangle I can find is angle C. Because we're given two angles and the sum of the angles in a triangle is 180, we can go ahead and solve for angle C. Doing 180 minus 108 minus 23, and we get angle C as 49 degrees. Now we have all three angles in one side, we can set up what we know in the formula for the law of sines. So we know sine of 23 over side A equals sine of 108 over B equals sine of 49, and then we actually are given side C, which is 7.7. So we know angle C and its sides, so we're going to use that ratio to help solve for sides A and B. So we set up the ratio to solve for side A. We have that sine of 23 over A has to equal sine of 49 over 7.7. So in order to solve for side A, we're just going to cross multiply. So A times sine of 49 has to equal 7.7 times the sine of 23. And then to get A by itself, we're going to divide by sine of 49. And in order to get the most accurate solution, you're not going to want to have decimals until the very end. So don't do 7.7 times the sine of 23 and write the decimal, because then your answer is going to be off in the end. So what we want to do is 7.7 times the sine of 23 and then immediately divide by sine of 49. And if you round two decimals, you should get A as 3.99 centimeters. It's also very important that you make sure that your calculator is in degree mode as well, otherwise you will end up with very weird answers. So let's go ahead and set up the ratio to solve for B. So sine of 108 over B equals sine of 49 over 7.7. And again, we're going to cross multiply. So B times the sine of 49 equals 7.7 times the sine of 108, divide by the sine of 49, and we're going to get that B is about 9.7 centimeters if you plug that into your calculator. So let's do another example. So in this triangle, we're given angles A and C, so we can go ahead and right off the bat solve for angle B by subtracting 131 and 11 from 180. We're going to get angle B is 38 degrees. Now setting up what we know into the law of sines, we have sine of 131 over A equals sine of 38 over B equals sine of 11 over 0.65. Since we are given side C. So again, set up the first ratio to help us solve for side A. So sine of 131 over A equals sine 11 over 0.65. Again, we're going to cross multiply. So A times sine 11 equals 0.65 times sine 131. Divide by sine 11. And we're going to get A is 2.57. In this case, our units are miles. Now we're going to solve for side B. So we're going to use sine of 38 over B equals sine 11 over 0.65. Again, cross multiply. So B times sine 11 equals 0.65 sine of 38 divided by sine 11, and we get B is 2.1 miles. As I said, this is the easiest case for law of sines. It's pretty straightforward. You always solve for the angle first, and then you can set up and solve for the remaining two sides. But as I said, there is a second case to the law of sines, and that is when you're given two sides and the non-included angle. So this would be that side-side angle case of similarity, which, as you know, doesn't always work. And that's where you get a kind of the ambiguous case in the law of sines. So you don't necessarily always have a unique solution. You can actually have two triangles or no triangle, or you could have one triangle. So there's actually three possibilities if you're given two sides and the non-included angle. So let's go ahead and take a look at this. So in this picture, it's helpful to know that in here, H represents the height of your triangle. And the way that we find the height in a triangle when we're using law of sines is to take our height, take our side known as B, and multiply it by the sine of angle A. That's how you're going to be able to use the comparison to determine what types of solutions you have here. So you need to find the height of the triangle by doing your other side B times sine of angle A. So let's look at this first case here. We have no possible triangle if when you find that height, your other side A is less than that height. So if A is less than the height, then no triangle exists. It's pretty straightforward. Our second case is if A equals the height. That's going to be a right triangle, which for us is not very useful since we know how to solve right triangles. We've already talked about that. So what we're going to be looking at is mainly this third case, where your side A is greater than the height, but less than our other side B. This is the case where you can get two possible triangles. You can get two different values for A, and then your angles, the last two angles B and C, are also, you can get two different solutions for C, and then same for the angles. You can get different angles as well. And then our last case is if your side A is greater than or equal to B, it's going to be one triangle. So we're going to go ahead and apply these in our last few examples to figure out if we can even solve the triangle. So we first want to determine the number of solutions possible, and then, if we can, solve the triangle. So in our triangle, we're given angle A is 25 degrees, side A is 13, and B equals 12. So if you want, you can go ahead and draw the triangle just to see it a little bit better. If you want, if you are a visual learner, you can go ahead and draw the triangle and label what you know, but it's not necessary. So if we go ahead and use that previous page to help us determine the solutions, we can start off with that last case. So in this example, A is greater than or equal to B, since 13 is greater than 12. So right off the bat, we know there's going to be one solution for the triangle. Your other option is if you go ahead and find the height. A is greater than that, but we don't need that because it meets that fourth case. So we're going to go ahead and solve our triangle. So let's go ahead and set up what we know into the law of sines. So we know sine of 25 over 13 equals sine of B over 12, and then we have sine of C over C. So the first thing we're going to do is use the law of sines to find our missing angle B. Because once we know our missing angle B, we can find C, which will then help us find that missing side length. So if we set up that ratio, sine of 25 over 13 equals sine of B over 12. Just like before, when we're solving for sides, we are going to we don't actually have to cross multiply. Since B is in the numerator, all we have to do to get sine of B by itself is to actually multiply both sides by 12. So we get sine of B equals 12 times the sine of 25 all over 13. So what we want to do now is to find the measure of angle B. And from section 4, to find the measure of an angle, you do the inverse. So we're going to do the inverse of sine to both sides. And it is going to work out best, again, if you just go ahead and do this all in your calculator in one step. So we're going to get that angle B is about 22.96 degrees. There is a way to do this if you do it in multiple steps. You should still get something very similar to 22.96 if you go ahead and use a decimal for 12 times the sine of 25 over 13. So now that we know angle B, we can go ahead and use the triangle sum theorem to find angle C. So C is then going to be 180 minus 25 minus 22.96, and it's going to give us 132.04 degrees. So now to find side C, we have to set up the law of sines again, this time using our last ratio. We're going to use the sine of 25 over 12 over 13 as our other ratio. Now that we know angle B, we could use that one, but because we had to round and we got a decimal, it's always best to use exact numbers you're given to solve for missing sides and angles. So sine of 132.04 all over C. This case we do have to cross multiply, so C times sine of 25 equals 13 times the sine of 132.04 divide by sine of 25. And we get that C equals 22.85. And we aren't given units in this case for the sides, so it's just going to be 22.85 units. Moving on to our second example. Our triangle, we have angle A is 125 degrees, A is 35, and B is 45. So in this case, we do have to figure out the height because we're not sure if there's no solution or two possible different triangles here that can be formed. So to find our height, we have to do our side B times the sine of our angle A. So that would be 45 times the sine of 125. So our height is going to be approximately 36.86. And our given side A is less than H, since 35 is less than 36.86. So because A is less, there is no solution. So this would be a case where no triangle can be made with that given angle and those two sides. So let's take a look at our last example. So angle A is 25 degrees, A is 5, and B is 10. So again, we have to first start with finding the height. So B times sine of A, 10 times the sine of 25. So our height is going to be about 4.22. So in this case, A is greater than our height, since 5 is greater than 4.22. But it also meets the requirement of our side A being less than our given side B, since 5 is less than 10. So this is the case where we have two possible triangles, which means there's going to be two different lengths for side C and two different possible angle measures for B and C. So let's go ahead and set up what we know. So we know sine of 25 over 5 equals sine of B over 10 equals sine of C over C. So first we're going to use our ratio to solve for our first possible angle of B. So sine of 25 over 5 equals sine of B over 10. Multiply both sides by 10. Sine of B equals 10 times the sine of 25 over 5. Then we're going to have to take the sine inverse of both sides. So angle B (57.7 degrees). Now we can find angle C, since we know 180 minus 25 minus 57.7, we get 97.3 degrees. So now we're going to use that angle C to solve for side C. So we have sine of 25 over 5 equals sine of 97.3 over C. Cross multiply. C times the sine of 25 equals 5 times the sine of 97.3. Divide by sine of 25. And we get C equals 11.74. So now we have to figure out the second possible solutions for angles B and C and side C. So in order to do this, we go back to when we took the sine inverse of 10 times sine of 25 over 5. So your calculator is going to give out 57.7 degrees. But there is a second angle that will give us the same ratio for sine for the decimal if we were to find it. And in order to find that, we have to actually do 180 minus 57.7. And we're going to get 122.3. And this is our actual second possible solution for angle B. So now we have that B can equal 122.3 degrees. And if you do take the sine of 57.7 degrees and the sine of 122.3 degrees, the decimals are going to be a tad off because we did round, but to 2 decimals, I think even 3 decimal places, they are the exact same. So our second possible solution for angle B is 122.3 degrees. So now to find our second possible measure for angle C, we do 180 minus 25, the angle we originally given, minus 122.3, and we get angle C can be 32.7 degrees. So now to solve for side C, we're going to set up the same trig ratio with sine of 25 over 5 equals sine of 32.7 over C. We're going to cross multiply, so we get C times sine of 25 equals 5 times the sine of 32.7. Then we're going to divide by the sine of 25. And our second possible solution for C is 6.3